Hi, my name is Sean and I'm from Team 7. On behalf of my team, I will be sharing with you our AD project SG Locum Finder today. Before I commence my presentation proper, allow me to set the context first by briefly talking about the problem that our solution seeks to solve. In Singapore, GP clinics often rely on a pool of part-time doctors, also known as locums, for their daily operations. The current process of hiring locums is highly ineffective now, as clinics often rely on their private mailing list or ad hoc job postings on general job search website to look for doctors. Doctors in turn often have to search for locum opportunities at different places, as the information could be lying anywhere. Administratively, all parties involved in the process would also need to track everything manually, and this in turn creates additional administrative burden for them. The solution that we have developed seeks to provide a centralized portal where all end-to-end workflow, including the creation of job posts to administrative matters such as paying the doctors involved in the hiring of locums, can be performed. This presentation will be split into two key parts. I will first be doing an end-to-end walkthrough of the entire system from the perspective of three key categories of users, namely the clinic, the doctor, and the system super admin. For the clinic and the system admin, they will be using our browser-based web application to perform the necessary functions. For the doctor, we have developed a mobile application to facilitate their usage. Finally, I will take the opportunity to highlight some interesting aspects of our code. I will now start with the walkthrough of our platform by assuming that there is a new healthcare institution which may be interested in using our platform to look for locums. Before it can even do so, the healthcare organization will need to register itself. To do this, the user can just click on register a new account, then click on register, enter the required information such as the organization name, UEN number, etc. When this is done, the user registering on behalf of the organization will need to enter his or her details so that an admin account can be set up too. For the admin account, the person will be requested to enter the common information required for account setup, such as the preferred username, password, etc. Once the organization and admin account are successfully set up, the user will be immediately brought to the landing page, which comprises a dashboard. I will talk more about the dashboard later, but for now, the next step involved for a newly registered organization will be to create clinics before any jobs can be created. To create a clinic, the user can just click on Add Clinic via our navigation bar on the left side. The navigation bar is designed to provide the end user with ease, as the key functions commonly used by the end user can be found there. For the adding of the clinic, the process will again involve the entering of key information required, including the clinic HCI number, which is a unique identification number issued by MOH in Singapore to all medical premises. More often than not, large medical organizations, such as the like of Raffles Medical, will have multiple clinics. So if necessary, the user can create more clinics. After the clinic is created, we can now proceed to create the job post. Again, we can click on Add Job Posting on the navigation bar. For creation of job posts, apart from things such as the title and description, what is critical will be the start date and end date time. In the event that an invalid date is selected, the user will be prevented from submitting the page. The clinic will also need to provide information on the hourly rates that the doctor will be paid. What is interesting over here is that we have within a Python time series model backend to help the clinic user have a gauge of what is the going market rate. Should the user enters a rate that is something that is substantially below the market rate, as we have defined as more than 20% below the market rate, a warning message will be shown to inform the user about this. Backend, this going market rate is computed by taking the average rates of actual jobs that have been accepted or completed in the past 14 days or 28 days. On the other hand, these rate warning messages will be gone if the rates are close to the actual market rate. When ready, the user can click on the Create button. After the job is created, the user will be able to view the jobs created under View Job Post tab, including those that were previously created by either the user himself or those created by his organization. We will now move on to the perspective of a freelance locum who seeks to find a part-time job via our mobile app. Similar to an organization, a freelance doctor will also need to create an account before he or she will be able to view the jobs. For the registration of the doctor, he will need to do so via our mobile app by clicking on the register button. He will then be requested to enter the required information, including the username and password. When done, the user will immediately be logged in and he can then start using the platform. After logging in, the user will be presented with a dashboard containing useful information to him or her. To search for jobs that he or she may take up, the user may then click on the search button to view the available jobs in the market. To make the job search process more efficient, my team has also incorporated a backend Python machine learning model to filter out jobs that are similar to the user's past preferences. I will spend more time to explore the model's code later, but suffice to say now, the model relies on 4 variables, namely the duration of the job, the time period of the job, the location and day of the week to compute the recommendations. For viewing of the jobs, they are sorted in ascending order, and those jobs that are nearest to today's date will be displayed on the top of the screen. To view more details pertaining to a job, the user can click on the job. If there are any additional information available, it will then be displayed to the user. Should the user be interested in the job, he can then apply for it. After the user has applied for the job, the status will be changed to accepted. After the job is accepted by a local doctor, the clinic will need to confirm the job posting. We will now go back to the perspective of the clinic. As mentioned earlier, to view the job, the user may first click on View Job Postings to manually search for them. Alternatively, the user will actually be able to see the status change on his or her dashboard too. The user can then click on the job directly and open it up. To confirm the job, the user just need to click on Confirm Locum. Should it be necessary, the clinic can still cancel the job even after confirming it. Similarly, this can also be done by the doctor, as is common in the industry currently. After the job has been confirmed, the next step will be for the clinic to confirm that the doctor has shown up on the scheduled job date. For changing of the status of the job to completed, our platform has catered for situations whereby the actual timing of the job performed differs from the original scheduled time. For example, there may be occasions when the doctor is required to stay back slightly after the scheduled time because the clinic may be crowded that day. In this context, the clinic will need to reconfirm the actual start date and end date again. At the same time, the clinic may also add in additional fees. In the market currently, some organizations may pay the doctor a variable fee, such as $5 for every patient seen. This can be included as part of the additional fee. When done, the user can click on Set as Completed, Pending Payment to update the job status. For the clinic user, after the job is completed, the clinic will still need to process the payment to the doctor. This is the final stage of the workflow, but nonetheless an important one, as getting paid is something that is commonly on the top of the mind of the locums. Again, the clinic can update the payment status by clicking on Set as Completed Payment Process. We will now go back to take a look at the locum perspective. Unlike in the past, when locums will need to track the jobs they have performed manually, our mobile application makes it easy for the locums to track all administrative matters related to the job that they have accepted. When there are new changes, such as when payment was actually made by the clinic to the doctor, they will automatically be notified via the app, as updates will be pushed to them via the Firebase API. This will help to make our entire solution more operationally efficient, as users are immediately notified of new developments and thereby reduce the chance of a situation whereby either side misses a message from the other party. Apart from push notifications, the doctor may also open up the My Jobs tab on the mobile application to track those jobs that he had either accepted or completed. This will mean that the doctor will no longer need to open up his inbox to check or even call up the clinic to check if payment is ready made to him, as everything is contained in one single place. Let's now go back to the web application to look at how the platform can be used by our super admin. Let's now take a quick look at how the platform can be used by our system admin. From the system admin perspective, he will primarily perform the administrative task of ensuring that job posts are appropriate and any errant posts, organization, users are removed from the community. Similar to a clinic user, the system admin will log in via the web application, and he will be presented with a dashboard that will allow him to monitor some metrics that are likely important to his company. For example, the company that operates this platform will likely be interested in the growth rate of the user base on the platform. At the same time, the company will also be interested to know the number of job transactions that had taken place on the platform. These metrics serve as a proxy of the business health of the entire platform. With regards to the system admin responsibility of ensuring that rules within the community are followed, he can actually view all the jobs that are created and remove them if necessary. In some situations, there may be a need for a system admin to remove an entire organization entirely. In this context, the system admin can also come to manage organization page to deactivate an entire organization. By doing this, all users in the organization will also be deactivated. Alternatively, the system admin can also deactivate just a single user. In some situations, the system admin may need to help with the modification of some user details. The system admin will be able to do so by clicking on Edit button and modify the information. In some situation, the system admin may also be contacted to help reset the password. The system admin can click on the Send Reset Password email button to trigger a change password workflow. When triggered, the user will receive an email which will allow him to change the password. I will now show you an example of the reset password email that was triggered by the system. All emails triggered by the system admin is sent out by the designated email account sglocumfinder@gmail.com. When the user opens up the email, he will find a link that will bring him to a page where he will be requested to type in his new password. As this email will be sent only to the registered email account of the user, this ensures that only the user himself will have access to it. As an additional security feature, once this reset password link has been used once, the user will no longer be able to click on it again. Apart from password reset related matters, we have also configured our system to also send out emails to users whenever there are critical updates to the job post they have applied to. For example, after a clinic confirms or cancels a job posting, the locum doctor will receive an email informing him that there is a cancellation. Together with the push notifications, this feature helps ensure clear communication between all parties and therefore add to the user-friendliness of our solutions. Lastly, before moving on to the next section of this presentation, I would also like to spend a minute to talk more about our clinic user dashboard.
When it comes to dashboard design, the key principle guiding us is to provide information that is useful to the user's job. For a clinic user, his key responsibility with regards to using our platform will be to help his organization fill the part-time locum positions. When a clinic user opens up our application in the morning, we envision that the first thing he would be interested in is the number of unfilled jobs and the number of upcoming bookings. The pie chart on the screen will also provide the clinic user an overview of the status of all the job posts that he has created, and therefore give him not just a sense of the matters he will need to follow up on, but also the volume of those matters. At the bottom of the page, we have also filtered out the last changes performed by the user and the latest job post updates. This will help us to serve as a reminder to him on what he may need to continue on from yesterday. Historical metrics such as the cancellation rate, average job take-up speed, and moving averages of the market rates for locum are also presented to the user to help him anticipate potential operational issues that may arise. For example, the average job take-up speed helps inform the clinic user how much buffer time may be needed to fill a position. I will now move on to the second half of the presentation, where I will highlight some interesting parts of our source code. This diagram provides a high-level overview of how the source code is structured. The solution comprises a mobile application built using Android Studio and a Java Spring web application that not only provides user interface for clinic users, but also interacts with the database on behalf of all the key user-facing applications. In the Java Spring web application, the code is separated into a few key layers, namely the controller, service, model, and repository layers. In addition, we have deployed two machine learning models. The first model utilizes cosine similarity to recommend suitable jobs to the locum user based on past historical preferences. And the second model, a time series model, which helps the clinic user to have a gauge of the current market rate. With the exception of the mobile application, we have deployed all the source code on AWS.
We will now take a closer look at our Python script for the job recommender. The Python script begins by first calling the API to get data from the Spring server. In particular, it retrieves two sets of data. First, it retrieves all jobs that are open. Then it retrieves all past job transactions along the locum ID. The Python script then proceeds to prepare the data by using one-hot encoding to extract four important information from the raw data. The four important information are the day of week, the duration of the job, the start time, and the location. After the data processing is completed, the script then proceeds to identify the top three most common combination historical job choices for each doctor. After this is done, we can then make use of cosine similarity to filter out those jobs that are most closely related to the doctor top three choices. The results are then persisted to the database by the Python script. The script is run every 1 hour so that the system will have up-to-date recommendations. We will now take a look at the time series model. The time series model is incorporated into the web application to provide clinics with a sense of what is the going market rate. For the time series model, the Python script will first retrieve all the accepted jobs that were scheduled for yesterday to compute the average rate for that specific day. After this is done, the model will then use this computed daily rate to compute the 14 days and 28 days moving average. This data is then persisted back into the database. When the clinic user attempts to create a new job, the controller will retrieve these moving averages data from a database and then reflect it in the time leaf HTML page. Similarly, the script is scheduled to run on a regular basis, but for this time series model, we have scheduled it to run only once per day. Lastly, I would like to also briefly touch on how notifications that are triggered by events such as cancellation of jobs are done through the usage of Firebase Cloud Messaging Server. When the Locum user is first registered, what we did was to register the user mobile device with the FCM server. In exchange, the FCM server will issue us back with a unique token that will then be tied to the user. This data will then be persisted in the database alongside the token ID. Whenever there are events which we want the users to also be notified after these events are effected, the token will then be retrieved and sent back to the FCM server alongside the message we want the user to see. We have now come to the end of this presentation. I hope this has given you a better idea of our SG Locum Finder solution. Thank you.